Anybody brave want to sing it? Come on, don't be shy. We're all friends here. Don't pretend like you don't know.
Well, I don't remember it. I don't want to sing. Pop goes the weasel. Da, 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 da. You think Roberts will sing it?
Yes.
I don't know if he's here. Is Roberts here today? He was gone yesterday. It's like way down the hall over there.
All right, let's go bug Mr. Roberts. From way across the hall, we have Mr. B.J. Roberts.
Are we recording right now?
We're recording.
Okay. My teacher dressed up as a weasel. It goes to the tune of Pop Goes the Weasel. Has everybody heard it? Brian has. Yes, right? Alright. Here we go. X equals negative b plus or minus square root of b squared minus 4ac all over 2a.
Yeah!
Everybody, if I see a mouth today going, I will sit upon you. I know it's going to be you. Okay?
I'm watching
Here we
Colby.
go.
X equals negative b
Plus or minus the square root of b squared minus 4ac all over 2a. I guarantee if you were to do that, you'll memorize it.
Yeah!
Thank you, thank you.
Thank you, Mr. Roberts.
Yeah.
All right. Let's use a formula now. We can't factor this one. Nothing multiplies to one that has 3, so we got to use a quadratic formula. Early on, I've noticed students struggle finding the values of a, b, and c. Where does a come from? A is the number in front of x squared, which in this case is 1. B is in front of the linear term. It's just the number, though. It's not the variable. B is 3, not 3x. And c is 1. Okay, so x equals, help me out here, negative 3 plus or minus square root of 3 squared, which is 9, minus 4 times a times c all over 2 times a. All over 2a. I don't know why this happens. I really don't know why this happens, but 90% of the mistakes that occur happen right here. I truly do not understand why this is so difficult. You really can't put this whole thing into a calculator. You could put this into a calculator, the 9 minus 4 times 1 times 1. That's what I would, I mean, maybe not for this one, but I think the problem is a lot of students think, hey, I can just do this in my head, when in reality, no, you can't. Okay? Don't try to do too much in your head, because it's full of weird stuff in your teenage years. So use your calculator. What's 9 minus 4 times 1 times 1? 5. Okay? It really doesn't take that long to do on your calculator. You do 9 minus 4, parenthesis 1, parenthesis another 1, enter. That took like 4.78 seconds. Right? So, anyway, negative 3 plus or minus the square root of 5 all over 2. Now, sometimes when you're using the formula, you can stop here, like this time. We're done. Formula's over. Why are we done? You can't simplify square root of 5. Right? What if on a different problem, though, let's say that happened to be an 8 or something. Can't you simplify square root of 8? So you'd have to continue to simplify. But for this, the square root of 5, it doesn't go any lower than that, so that would be the answer for that problem. Okay. So let's do number 9. Not number 9. What is it? Yeah, number 9. Let's take a look. Number 9. So it was, if I remember right, x squared minus 8x minus 18, right? So you can do this on your worksheet. You don't have to do this in your notebook.
We're going to keep going back and forth, though, so don't put your notes away.
A equals 1, correct? B equals negative 8, and C equals negative 18. I always write the values down so I know what they are. I'm not confused on what A, B, and C are. Now, let's use the formula. X equals the opposite of B, or negative B. So what am I writing there? 8, positive 8, plus or minus the square root of B squared. Now, I really shouldn't have to be explaining this, but I see this. I've seen it 3 times today already in my other class before this. Negative 8 squared.
64.
Here's what the problem is. Students will go, okay, negative 8 squared. Oh, negative 64. Let's move on. Do you see what the problem here is? A negative times a negative is positive. Anytime you square something, it's always positive.
Is the calculator wrong here?
No, you just typed it in wrong. If you want to square a negative on these calculators, it has to be typed in like this. Anywho, just so you know, that's a silly mistake that shouldn't happen. So anyway, B squared minus 4 times A times C all over 2 times A, or which is just 2. Now here's what I meant by not trying to do this in your head. Okay? 64 minus 4 parenthesis 1 parenthesis negative 18. It's so easy to do this on your calculator. 136. So Dallin, you were saying, all right, how do we know when we need to continue on or if we stop here? Does 136 square root evenly? Like, is 136 a perfect square? No, it's not.
But there may be something that divides into it, like 9 or 16 or 25, or one of those numbers might divide into it evenly.
So to the calculator. Do any of those perfect square numbers divide 136? Don't wait for me to do it. You guys can do it. Get your calculator out. Start dividing it by perfect squares until you get one that divides evenly. You got 4?
I got 4.
4 and what? 4 times 34. I think that'll work. So you need to rewrite this as 8 times the square root of 4 times 34. All over 2. Now what? Really, you guys, this is stuff from last year. The quadratic formula was a huge part of secondary 2.
Where do we go from here? Why would we have switched 136 to 4 times 34? Is that just pointless? I'm trying to simplify this, right? Square root of 4 times 34 is the same as the square root of 4 times the square root of 34. Those two things are exactly the same. And what's the square root of 4? 2. So that changes into 2 square root of 34. Now are we done? Still not. Is 8 divisible by 2? Is 2 divisible by 2? Why am I saying divisible by 2? Because there's 2 down here. Okay? If both of these numbers are divisible by the same number down here, then you need to continue to simplify. There's different ways it could be done. Some instructors teach it differently. This is the way I found that you're going to make the fewest mistakes. Okay? What did I just do here? What did I just do there? Instead of 1 fraction, I made it into 2 fractions. Is that okay to do? If I were to combine this again into 1 fraction, wouldn't you get that anyway? You guys okay with what I did? Why am I doing it this way? I just see fewer mistakes. Now you can clearly see that the 2 simplifies with the 8 and the 2 simplifies with that 2 right there. So what's 8 divided by 2? 4. And then the 2's cancel, so you're going to get 4 plus or minus the square root of 34.
Okay.
Now check the answer. Is that your answer's on the back, right? Is that you better check. Did we get it right? Yeah. Yay for us. We're the best. Yeah, I think they probably write it as 2 separate ones, right? Just do it as plus or minus. So switch it over to the back. Are there some from the back we haven't done yet? Well, we're not going to get to 11. Just cross it out. Now, 12, I think we can do. No, scratch that. I know.
We can do 12. I know we can do number 12. There's one additional step on number 12. Do you know what I'm talking about? Isn't there one additional step on number 12 that we didn't have to do on this last example? Look at the whole equation, you guys. Does it start off with x squared?
No. Quadratic formula only works with x squared. Let's take a look at all 3 terms. They have an x. All of them have an x in common? Yes. All right, so factor that out. Factor out an x.
So if you factor out the x, now you have an x squared. X squared, help me out, x squared plus, or was it minus, what is it? Minus 4x plus 20 equals 0. Now it's always worth checking. Don't just assume because it says use the quadratic formula that you have to.
Does this factor? Because if it factors, that's a way easier way of doing it. Does anything multiply to 20 that adds to -4? Multiplies to 20, that's 5 and 4, or 10 and 2, or 20 and 1. Can you combine any of those to get -4?
So, no, it doesn't factor. Darn it. Ooh, can anybody tell me one of the answers right now? Without looking at the answer sheet, you cheaters?
How do we know one of the answers is going to be x equals 0? We factored out the x on the outside. There's one of your answers, x equals 0.
All right, so we're a third of the way done because we found one of the solutions. Well, this part has to be solved with the quadratic formula. So, let's do it. X equals the opposite of b, or negative b. So it's got to be positive 4, right? Because here it's negative, so we've got to do the opposite. So positive 4 plus or minus the square root of b squared, which is negative 4 squared. Negative 4 squared is 16 minus 4 times a times c. I'm going to let you guys take a minute. See how far you can get on that one. The Doesn't happen very often where you end up with a perfect square underneath here. But it is nice when it does. So 16 minus 80 is negative 64. So you have 4 plus or minus square root of negative 64 all over 2. Square root of 64 is 8i. So you have 4 plus or minus 8i all over 2. So I would change that into 4 over 2 plus or minus 8i over 2, which is 2 plus or minus 4i. Now, just so you can kind of plan ahead, and I'm just anticipating some mistakes.
Is this the solution right here? 2 plus or minus 4i? We forgot one, right? So on a test, if you circle this and forget the other one, I will have to mark it wrong. What's the other solution?
0. Don't forget to include all the solutions. X equals 0 as well. X equals 0, X equals 2 plus or minus 4i. We good? Now, I need to go back and clarify something.
You remember during the quiz how I said, hey, if you want to solve these equations, what can you do rather than factoring? Didn't I say you could use the graph and take a look at where it crosses? Remember I said that? I need to clarify that a little bit. You can still do that. It's not that you can't.
What type of number is this right here?
2 plus or minus 4i. It's imaginary, right? Do imaginary numbers really exist? So think about in terms of a graph. Is this right here going to be an x-intercept, x equals 0? Absolutely. Is this going to be an x-intercept? No, it's not.
So when you look at this graph right here, it still wouldn't be a bad idea. If I were to type this in, it is, what, x to the third? What was it, x to the third? Minus 4x squared plus 20x. Thank you. So we can't see the whole graph. It's not, it's just we can't see it all. I'm going to zoom out. That didn't help. Zoom back in. Well,
Just for sake of time. Where's the only point that it's crossing through the x-axis? So if you were to look at that, you might think, hey, there's only one solution. Is that accurate? Is there only one solution? Because this is an x to the third, right? How many solutions do there have to be? There's got to be 3. There's one real solution, which is x equals 0. If there's only one real solution, what does that mean about the other two? They're imaginary solutions. Okay, plus or minus. Do you understand what I'm talking about? Not all solutions are x-intercepts. Only real solutions, like x equals 0 or x equals 10. You follow? You need to understand that. Okay? Engineering.
electrical engineering a lot of times uses imaginary numbers. Matter of fact, that's pretty much all they use. If we didn't have imaginary numbers, you guys wouldn't have your cell phones or iPods. Think about that. Okay? So, they pretty much made the modern era possible, you guys. Imaginary numbers. So show some respect, dang it. Now, this is a new topic. We've got 4 more questions to go, don't we? New topic. Ooh, it's the sum or difference.
So last time we went over the difference of squares, right? Like x squared minus 9 or x squared minus 25. You remember me asking you if x squared plus 25 is possible? Can you factor x squared plus 25? No, because it's the sum of squares. You can't do sum of squares. But you can do sum or difference of cubes.
You can do both. It's just a little formula. So let's do the difference. Well, if you need to write this down, write this down. This was the difference of squares formula. If you happen to forget,
it's there for you. I think we wrote this down last time, though.
So maybe don't write it down because you already have. I just wanted you to see what that formula is. Is that hard to remember?
The difference of squares formula? Not that hard.
The difference of cubes is a little more difficult to remember. So, wait for it. All right, we waited long enough. That's the difference of cubes formula.
If you're subtracting two perfect cubes, like question number 14, for example, x cubed minus 8. You guys are very, very good at perfect squares, and that's awesome. 9 is a perfect square. 25 is a perfect square. 121 is a perfect square. You guys know all those. You need to become equally as familiar with perfect cubes, like 8. Why is 8 a perfect cube? 2 times 2 times 2. So 8 is a perfect cube. What's another perfect cube? 27, because it's 3 times 3 times 3. 64 is a perfect cube, because it's 4 times 4 times 4. Let's do one more. What's the next one after that? 125, because it's 5 times 5 times 5. Those are all perfect cubes. You need to become familiar with those.
So here's how it would look with an actual expression. Let's do x to the third minus 8. Why does this fit the difference of cubes pattern?
Well, first of all, it's difference. It's minus, right? Why is it difference of cubes? 8's a perfect cube. X to the third is a perfect cube. So it's this difference of
two terms that are being cubed. One mistake students make a lot of the time
is to use 8 in the formula, and they put an 8 right here and an 8 right here. Are we supposed to use 8? What are we supposed to use? 2. Why 2? Where'd 2 come from?
It's 2 cubed, right? It's x to the third minus 2 to the third. So your a value is x and your b value is 2, not 8. Your b value is 2.
So when you use or apply the formula, a minus b becomes x minus 2. Yeah. Yep. So you're going to get x minus 2. And then x squared plus 2x
plus 4. Where'd the 4 come from?
b squared, yep. And if b is 2, 2 squared is 4.
This you probably ought to try to remember. Once you have used the formula, this expression right here, whatever it is going to be prime. That means it doesn't factor. So you will never be able to reduce this down into two smaller factors here. Do you understand what I'm talking about? What does that mean we're going to have to do? If this doesn't factor, what are we going to have to do? Quadratic formula. Let's do number 14. This is number 14 right here. X to the third minus 8. Now, it's not a bad habit to get into because it doesn't take that long. I'm just going to graph this to see what the graph looks like. X to the third minus 8. What is this at least going to tell me? N behaviors and how many real solutions it has. Take a look. How many real solutions does it have?
How many times does it go through the x-axis? So it has one real solution, but it's supposed to have 3 solutions, right? If one of them's real and the other 2 are imaginary, those have to be found with the quadratic formula.
So first thing we're going to do is factor it using the difference of cubes formula. Didn't we already do that? It's right here. So you factor it first.
You can write this on your worksheet. This is number 14.
So when we get the real factor from the x minus 2, so I get the real intercept, and then we
Yep.
get the
Exactly. Do you notice on the graph the answer? Let me put it back up. On the graph, didn't it cross right through 2?
Yeah.
And that's where it comes from right here, this x minus 2. Unfortunately, though, this x squared plus 2x plus 4, that has got to be solved with the quadratic formula. So if you set each factor equal to 0, this is where the x equals 2 solution comes from. So we've used the formula twice now. I'm going to show you again how to use it. You guys see how far you can get on the formula, and we'll come back to this and see what the answers are. So go, try it. If you plug things in correctly to the formula, you're going to have this. X equals -2 plus or minus square root of 4 minus 4 times 1 times 4 all over 2. That's what should have been put into the formula.
Okay. What's 4 times 4? 16. So this is 4 minus 16.
4 minus 16 is -12. So then the next step would be -2 plus or minus the square root of -12 all over 2. All right, square root of -12. Let's take a look at that. The square root of -12. There's a lot of things that multiply to 12. 1 times 12, 2 times 6, 3 times 4. Which one of those has a perfect square factor? 3 times 4. So we're going to use the 3 times 4 because it has a perfect square. I'm going to write it as the square root of -4 times 3. Why the 4 first? Doesn't really matter what comes first, but I always write the perfect square number first. What's the square root of -4? 2i. Yep. So the -4 comes out as a 2i, and the 3 stays on the inside. So it's 2i times the square root of 3. So that would be your next step, is to replace the square root of -12 with 2i root 3. Okay. Now, next step would be to, I guess it doesn't have to be done this way, but I do it this way. I split this up into 2 fractions. This is going to be -2 over 2 plus or minus 2i root 3 over 2. I just see students make far fewer mistakes when they split it up into 2 separate fractions. What's -2 over 2? -1. And then here the 2's would cancel. So you're going to get -1 plus or minus I square root of 3. What do you report? If this were a test, what would you report as your final answer? Just this? And x equals 2 as well. And x equals plus or minus -1 plus I root 3. And that's not the shortest process. I wish it could be quicker. It does get quicker if you practice it. Hey, guess what? We're not done yet. We've done the difference of cubes. What haven't we done? The sum of cubes. Hang in there, you guys. We got 5 minutes. Can you do it? It's 4th and goal. Clock's winding down. What are you going to do? Give up? Say, let's just lose the game. It doesn't matter. No, you win at all costs. Life's about winning. All right, let's finish this. The sum of cubes. It's almost, and I do mean almost, not quite. It's almost the exact same formula. Take a look. Yes, memorizing things is easier if you recognize patterns. If you can recognize a pattern, you memorize so much quicker. Is there a pattern between the sum of cubes and difference of cubes? Trust me, the patterns make it easier to recognize, to remember, or to memorize. What's switch? What's the only difference here? This plus and that minus switch. This is always going to be plus in the sum or difference of cubes formula, the plus b squared. It's this plus and minus that switch. How do you know which one goes where? The way I remember it, if it's the sum of cubes, the first one is plus, the second one is minus. If it's difference of cubes, the first one is minus, the second one is plus. But other than that, the formulas are exactly the same. So since they are pretty similar, let's do question 16. Do you see that it's almost exactly the same? So now we're going to do solve x to the third plus 8 equals 0. And we got to get crack-a-lack. First step. Use the... Yeah, what's been cubed here? So our b value is a 2. I'm going to write a little 2 underneath there. And our a value is x. Those are the numbers that it's going to go in the formula. So we have a little factor and a big factor. What are they? X plus 2. X squared. Minus x times 2, which is 2x, yep. Plus 2 squared, exactly. And that is 4. Now just compare real quick. This is number 16. Is it exactly the same as number 14? It's pretty close, but we are going to get some different solutions. So this one's pretty easy to get. If x plus 2 equals 0, that means x has to equal negative 2. So there's one of our solutions from this factor right here. Let's take this one over here and do the quadratic formula. X equals, I'm going to say positive. When I sing it, I say x equals the opposite of b, but negative b, apples and oranges, I guess. What's the opposite of b? 2 plus or minus the square root of b squared, so that's negative 2 squared, which is positive 4, minus 4 AC. All over. So this one's going to look almost exactly the same as the last one. Except here we have a positive 2 instead of a negative 2. So x equals 2 plus or minus the square root of negative 12 again, all over 2. And I know I showed you before, I'm going to show you again. Negative 12 you would split up into negative 4 times positive 3. And in case you're wondering, I am skipping a step that I very rarely show, but in case you're wondering why this works, if you're square rooting two numbers that are multiplying, it's the same as this. Two separate square roots, those are exactly the same. What's the square root of negative 4? That's why the 2i comes out and the 3 stays in. So, x equals 2 plus or minus 2i root 3. All over 2. So, if you split this up, you get 1 plus or minus 1i, or, just I square root of 3. So this combined with that